All right, 9.1 Polygon Basics. Going to go over the practice here, try to kind of break down how you do the problems. This is new since we're moving to online learning the rest of the year. So instead of me going over the homework or the practice in class, I'll be doing it on the computer. So hopefully you have access and you can check this out. All right, let's get into it. So number one, Polygon Basics, write the name for each polygon. Well, you name it by the number of sides. This one here has 6 sides. So that one is called a hexagon. The prefix at the beginning kind of tells you how many sides there are. This next one has 8 sides. So this would be an octagon. Right, moving on down. Number 3, state whether each one is regular or not. So, you know, the thing about regular, that means that you have all equal sides and all equal angles. So yes, this one is regular. All the sides are equal. All the angles here also are equal. This dude over here is funky looking. He's got a short side. He's got a longer side. He's got a medium side. So this one is not regular. So regular just means it's perfect. Perfectly symmetrical all the way around. All right. Find the measure of one interior angle. Round the answer to the nearest tenth. So interior angle, that means the inside. So basically we're trying to figure out how many degrees that is right there. How many degrees is there? So there are a couple different ways to do it. On number 5, I'm going to show you the first method, which is you can use the interior angle theorem, all right, or formula that works. And basically it is the number of sides, okay, whatever that is, take away 2. All right, so let's do the number of sides, take away 2. So we have 1, 2, 3, 4, 5, 6, 7 sides, take away 2. All right, and then you multiply by 180 degrees. So in general, the formula is n minus 2 times 180. And then you have to divide by how many sides there are. So we have 5 multiplied by 180. So what this is going to do, this is going to give me the total of all of the insides. So that's what, 500 plus 400, that's 900. So I know there's 900 degrees in the whole thing. But now I need to break it up. I need to divvy it up between however many angles there are. And on this problem, it looks like there are 7. So I need to do the 900 divided by 7, which I think is going to give me a funky answer here. Let me cheat and go to my calculator. 900 divided by 7, about 128.6. So it's about 128.6 degrees. So that's just for one inside angle. If we wanted the sum, all right, if we wanted the total, this would have been the sum of all of the inside angles. So kind of 2 formulas there you want to kind of keep straight. I'll do number 6 kind of the same way. And then 7 and 8 I'll do a little bit different. So let's get the sum and let's get each one. So the formulas are the number of sides minus 2. I don't know why I put 20 there. The number of sides minus 2 times 180. That's the total. And then if you want to do each side individually, you do the number of sides minus 2 times 180. And then you divide it by how many sides there are. So if you're a formula lover, this is kind of the route you would go. So on this one we have 6 sides. So 6 minus 2 times 180. So that's 4 180s, which is 720 degrees. So that's going to give me the sum. But now if I want each one individually, I need to take that answer and then divide it by 6, which tells me that each one is 120 degrees. So in a hexagon, every single angle on the inside is 120 degrees. All right, I'm going to show you a little bit different strategy, how I kind of do it a lot of times. And this way's a little nicer because you don't have to remember the formula as much. So number 7, we have a pentagon here. I like to start from the outside in, so I'm going to kind of work on the exterior angle. So from the video notes, you remember that an exterior angle, if you basically just take a side and you extend it out, what we create here is an exterior angle. All right, so this is the exterior. And the nice thing about this one is the formula is pretty easy to remember. The sum of the exterior angles, or the outside angles, it's always equal to 360, no matter what shape it is. So you don't have to worry about the n minus 2 stuff. I kind of like that. So when I think about all the exterior angles on this one, if I were to kind of extend this thing like a pinwheel all the way around, it looks like I have 5 of those. So if I want to find each angle separately, maybe I'll go a little fatter marker here. If I want to do each one separately, I just take 360 degrees and I divide it by 5 outside angles. And that's going to give me 72 degrees. So the cool thing is, I haven't really answered the question yet. I found the outside, but now the inside is really easy because the interior angle, which is what we're looking for, needs to form a straight line. It needs to make 180 degrees. So if I do 180, take away that 72, I'm going to get 108 degrees. So it looks like pentagons, if you wanted to build one, they're all going to be 108 degrees on the inside. Now, if I needed the sum of the interior, I could now just multiply the 108 times 5, and I would get 540 degrees for the total. So it just kind of depends on what you want. You can either start with the sum of the outside, go to the exterior, get the interior, and then go to the entire sum, or you can start from that inside and work out. So I'll do this one the same way. I'm going to start with the exterior. So the sum of the exterior is 360 degrees. I'm going to divide that by, well, let's see how many exterior angles I have. So I have 1, 2, 3, 4, 5, 6, 7, 8. This is 9 sides. So I'm going to divide that by 9. And I end up with 40 degrees. So every outside angle is 40 degrees. And then subtracting from 180 is going to tell me that the inside has to be 140 degrees. So each interior angle is 140. I really like using the sum of the exterior because I don't have to memorize the n formula. I just know that the angles all the way around add up to 360, which is pretty easy to remember because the circle is 360 degrees. So that's kind of how I remember the sum of the exterior. All right, moving right along, number 9. Let's see what we want here. Find the interior angle sum. So we're looking for the total in here. So not too bad. I'll use the formula on this one. So it's n minus 2 times 180. So this guy has 1, 2, 3, 4, 5, 6, 7 sides. So 7 minus 2 times 180. Well, that's 5 times 180. So 900 degrees is the total inside there. Next one, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has 10 sides. So I'm going to do 10 minus 2 times 180 degrees, which is 8 times 180. 800 and 640, I believe 1,440 degrees. Definitely double check me because I'm just kind of doing this in my head as I go. Try not to use a calculator too often so I don't slow it down. But if I screw up, definitely put something in the discussion comments during our office hours to let me know I screwed up. All right. Number 11. So kind of the same thing here. 6 sides, subtract 2 times 180 will give me the total of the inside. 4 180s is 720 degrees. This one has 8 sides. So that is 6 times 180, which is 600 and 480, which is 1080. So when you just want the total of the inside, the formula is probably faster. It would be slower to start with the exterior, work in, then multiply. Although you could do it, if you just want me to show you really quick, you could start with the exterior and go 360 degrees divided by This thing has 8 sides. So that comes out to be 45 degrees for each one. Then you could subtract from 180 to jump inside. So 180 minus the 45 is 135. And that basically gives me each angle. And then I can multiply it by 8 and get the 1080 that way. It's just quite a bit slower. So it all depends on what they want, which one you should use for speed. All right, number 13, find the measure of one outside angle. Well, I've already shown you how to do this a little bit. So basically, we're just trying to figure out, hey, how much would one of these angles right here be? Pretty easy. Start with the sum, and then just divide it by 5, because there's 5 angles. So the correct answer here is 72 degrees. For this one, if I want to figure out the exterior angle, this person is 360 divided by 6, which is 60 degrees. There's that answer. So not too bad. Looks like we get a little trickier here on 15 and 16. So number 15, find the measure of one inside angle in each regular polygon. Round your answer to the nearest tenth. So they didn't draw a picture, but they told me that it's a 21 gon, and I want one inside. So I need to find the sum. So 21 take away 2 times 180, which is 19 times 180. I'm going to cheat here. 19 times 180 is 3,420 degrees, which this would be the sum. This would be all of them. But now I need to, since I want to find one, I'm going to divide it by, there's 21 of those people. So divide that by 21, which looks like I have about 162.857-ish. So if I go to the nearest tenth, that means I want to stop there. So that 5 tells me to go bigger. So 162.9. Oh, and actually it looks like I included the answers here. So yeah, 162.9 shows up right there. So looking pretty good. And number 16, last one, we have a 23 gon. So do this the same way. 23 take away 2 times 180, which is really 21 times 180, which is 3,780. But then I had to divide it by 23 to just get one of them. So divided by 23, 164.3478, which rounds to, boom, 164.3. Looks good. All right, so that's kind of a breakdown of the 9-1 practice. Hopefully that helped clear up any issues that you had. If like I say, if there's more questions or you're not sure why I did something, make sure that you talk to me during office hours. See ya.